Um, Hi, Happy New Year. So this is January 1st, 2020, and I would like to make a video about this GitHub project. It's called mTCP. So mTCP is a highly scalable user-level TCP stack for multi-core systems. And so it works with DPDK. So the Intel DPDK project. So it is support DPDK, and yeah, so it's one of the user level TCP stack for DPDK, and there is some other TCP IP stack for DPDK, like the F stack from Tencent. But mTCP is a very simple TCP stack written from the scratch, and it's simple. So why I wanted to use mTCP stack? Because sometimes I wanted to do HTTP load test, and with mTCP and DPDK, it can generate a very high throughput HTTP request. And but the problem is mTCP officially does not support virtual machine. Say if you have a virtual machine running in a VMware ESXi cluster, and mTCP officially does not support it. So I had a very simple patch to make mTCP runs on the VMware ESXi virtual machine, and so here is this I forked the mTCP project, and this is a patch. It's actually a very simple patch to make it run on the ESXi virtual machine. So basically, the patch is to make the transmit TX descriptor ring size to be 512 instead of 128. So yeah, I can show you an example, and maybe it's better. So for example, I cloned the mTCP project on my virtual machine in VMware ESXi. So I git clone the project, and I make the code change. So this is the code change to make the transmit ring descriptor size configurable in the configuration, and so for example, number TX. Okay, I can. So this is the actual change. So DPDK module. Yes. So officially, the TX descriptor ring size is set to 128, which does not support the VMX Net 3 driver ring size, because the VMX Net 3 ring TX ring size, the minimum value is 512. So my patch is make this TX ring size configurable according to the driver. Okay. Okay. See. Let me show you code 128. So as you can see here, the default TX descriptor ring size is 128, right? And so the number TX descriptor ring size is set to 128, right? So that's the default setting. So this default setting does not work for the VMware VMX Net 3 driver. So when the DPDK TX queue set up a function trying to set up the queue for the NIC, it takes this TX ring descriptor size, which by default is 128, and this will not work for the VMX Net 3 PMD driver. So we can look into this function txq ring set size, and yeah. So here you can see TX from dev info. We can search. So we can search this TX descriptor limit, the minimum value for the specific driver, and you can see here this is for the this is a VMX Net 3. This is for the VMware virtual machine driver, NIC driver, the PMD driver. So if we go to 33, you can see the number, the minimum TX ring size. And if we check what is the value of default TX ring size, minimum TX ring size, it's 512, right? So the minimum size is TX ring size is 512. But in mTCP, DPDK module, it's set to 128. So it does not work. So that's why I made it a patch to make this value configurable, so user can configure. So I made a code change to add a config lum TX, so a user can configure this TX ring size. So that will allow VMware, that will allow mTCP runs on the VMware virtual machine. So I can give you an example here, like make a demo here. Okay. Need to say mTCP. So this is a mTCP client application and a configuration file. So in this configuration file, you can configure the TX screen size to 512. So then it will run. Okay. So anyway, let's start from the beginning. So you cloned the mTCP project and patched the code, and then you use this script. By the way, this steps is documented in here, the front page documented, so you can follow this step to set up mTCP and DPDK. So basically, I'm just repeat these steps. And so first you run setup mTCP DPDK. This is your local mTCP directory path to DPDK. So and you run this script. So first we gotta select 15 to compile the DPDK driver library. So this will take a little bit of time. Let's compile. In the meantime, let's go to the mTCP issues, because someone asked if he can run mTCP in a virtualized environment. So there's someone opened the issue report, and here I made a comment. So see, okay, here is basically just a one-line change. So this is I made a hard code a one-line change instead of make it configurable. So I just made a one-line hard code change to 512, and the second is yeah. So I also needed to configure the mTCP with DPDK library. You also needed to disable the hardware checksum. So this is also needed in my ESXi virtual machine. So that's the two requirements. One is to set the correct ring size, and second is to disable the hardware checksum. Okay, so the compile finished. Let's enter, and first we gotta insert the IGB UIO module, because after the compile, let's insert the. Okay, we inserted the IGB UIO module. Set up my huge page mapping for Luma system, because my virtual machine is Luma, has 2 load. 22. Let's give 2048 pages. Okay, set up the huge page. Then we bind the network device to IGB UIO module to bind it to so this is a network PCI bus info. This is an interface. I wanna use DPDK driver. Okay, so we bind the driver. We can display the DPDK driver here. So here it says network devices using DPDK compatible driver. So this PCI network interface is bounded to DPDK compatible driver. And the other two devices are just using a normal Linux VMware driver. Okay, so now we can exit, and in option 35 it will show the environment variable RT target, set it to this and set it to this. So are you using Intel NIC? Yes. We're seeing using DPDK compatible driver, and so it's run some script. So here it says register port 0 to mTCP stack. So the network interface name is called DPDK 0. Let's see. As you can see here, there is a DPDK 0 interface name, which is using a DPDK driver, VMware 3. So these two are just normal Linux interface with Linux driver. Okay, so let's bring up this DPDK interface and assign an IP address to it. DPDK 0. So now this we signed an IP address for this DPDK 0. So then we gotta compile the mTCP example app. Let's run make. So this just compile the EP server EP get to example app. Okay, so now we can run the app. EPWGET, which is basically a HTTP client to send the HTTP request to a server, to a remote server. And this is the argument I use. So this is a configuration file for the app, for the EPWGET app. And so this is number core, how many core CPU you want to use. So I just use 1 for now. So this is the number of total request, HTTP request. This is a concurrent request. So let's look at this config file, app config file. As you can see here, since I already patched the code, so I used the TX ring size 512 here. So let's run this app. Send a HTTP request to this IP address. as you can see, there's some counter here, just sending a packet, and let's go to a big IP. So this is I have a so my remote HTTP server is this one. So this IP address, right? So I can run TCP down. You will see the packet, right? So this is a HTTP request sending from the EPW get from mTCP to big IP. Yeah. So this is as you can see, there's some CPU request, CPU usage for TMM, because I'm only giving one CPU core for the mTCP, so the CPU stress is not that high, like 74%. And if I give it more CPU core to mTCP, it will stress the big IP system, right? So it's still running. Let's Control C to stop. All right. So another thing, before you run this client, you also need to have the proper ARP configured. So like say this is your remote server, HTTP server, and you need to give the MAC address. You need to give the correct MAC address to this IP address. So this is on big IP, and this is a MAC address 22BA, and here 22BA. So this virtual server give the correct MAC address. So that's one thing. And another thing is you have a route. So with this subnet, use DPDK 0 interface. So this is the ARP and the route for the mTCP configuration. And yeah, so this is how you can run a mTCP as a sort of a HTTP load test tool with high throughput with DPDK. And yeah, I hope the mTCP upstream can take my patch or maybe document it, and so people can run mTCP in VMware ESXi virtual machine. Okay, yeah, good, thank you.